We will now discuss the requirements which govern landing performance. These requirements include landing field length, approach climb, and landing climb considerations. The most limiting of these requirements defines the landing performance limited weight for dispatch. Let us take a closer look at each of these requirements, beginning with landing field length. Landing field length performance is developed from flight test demonstrated landing distances. These distances are measured from a height of 50 feet above the landing surface. The flight test landings are performed on a dry runway using an aggressive touchdown technique. Maximum manual wheel braking and speed brakes are used during the landing ground roll. Reverse thrust is not used or credited in the flight test demonstrated landing distance. The certified landing distance on a dry runway is the flight test demonstrated distance plus an additional margin of 67%. For a wet runway, the certified dry runway landing distance is increased by an additional margin of 15%. The landing field limit weight is the maximum weight for which the landing distance available meets certified landing field length requirements. This weight accounts for landing flap setting, wind and pressure altitude, dry or wet runway surface condition, and airplane stopping configuration. The landing field limit weight does not directly account for runway slope, non-standard temperature, or approach speed additives. These considerations are protected by the margins used to define certified landing distance. We will now look at climb performance requirements for landing. These requirements are based on the certified approach and landing flap combinations for each airplane model. Climb performance limits for landing ensure a minimum climb gradient capability in the certified approach and landing configurations in case a go-around becomes necessary at any point during the landing approach. For a 2-engine airplane, the minimum climb gradient required in the approach configuration is 2.1%. The approach climb configuration is based on the selected approach flap setting, with 1 engine inoperative, landing gear up, and the operating engine at go-around thrust. The approach climb capability is calculated at a speed not greater than 1.4 times the stall speed for the selected approach flap. The minimum climb gradient required in the landing configuration is 3.2%. The landing climb configuration is based on the selected landing flap setting, with all engines operating and landing gear down. The speed used for landing climb calculations may not exceed the certified landing reference speed for the selected landing flap setting. The certified landing reference speed must be at least 23% greater than the associated stall speed. Landing climb capability is based on thrust available 8 seconds after the thrust levers are moved from minimum flight idle to the takeoff position. The most limiting of the approach and landing climb requirements defines the climb limited landing weight. For a 2-engine airplane, approach climb is typically the more limiting requirement, whereas for a 4-engine airplane, Landing climb is typically the more limiting requirement. The climb-limited landing weight for the selected approach and landing flap settings accounts for airport temperature and pressure altitude, as well as engine bleed for air conditioning and anti-ice. Ice accumulation on unheated surfaces is also accounted for when operating in icing conditions during any part of the flight, with forecast landing temperature below 10 degrees Celsius. For operators who are subject to Joint Aviation Authority regulations, there is an additional climb performance requirement for low-visibility instrument approaches. The JAA minimum gradient requirement in the go-around configuration is the greater of 2.5%, or the published gradient for the specific airport, based on one engine inoperative and landing gear up. This requirement only applies to low-visibility instrument approaches with a decision height of less than 200 feet. The performance requirements which we have discussed in this module and the maximum certified structural landing weight define the maximum allowable scheduled landing weight for dispatch.